The following presentation is on source reduction and recycling activities and the methods to do so. The data is from the Environmental Protection Agency, and the program used is Python. The dataset contains facilities, chemicals, and the reduction methods used. These chemicals are being reduced and recycled to eliminate carcinogens released into the environment. By analyzing the type of facilities, chemicals, and methods, we can inspire more to reduce their chemicals. The following project was done using Python. I downloaded the dataset from the EPA website into a CSV file. Through this website, I was able to select all of the column names and variables that I wanted to analyze. I chose the facility name, the chemical used, the reduction method used, the percentage annual reduced, and the industry code. In Python, I was able to retrieve the CSV file using pandas. Then, using dictionary and renaming, I changed the column names and values into the dataset so they could be read easier. The EPA had a lot of code names and abbreviations that I wanted to change in the dataset so it would be easier to read. Next, I used value counts to find how frequent each of the items in the dataset were. This included the chemical names, reduction activity, facility name, location, type of facility, and many other things. Then I analyzed the data using plot graphs and tables. Imagine you are the manager of a facility that produces a lot of chemical waste. It would be better environmentally to start recycling the chemical waste, but you want to know how cost-effective this recycling process is and what the best methods are to do so. To properly make this analysis, you need information from facilities who are recycling their chemical waste, the chemicals they are recycling, and how effective this process is. The first thing you need to do is find which chemicals are the most common to be reduced, which is what I have done in the following table. The most frequently reduced chemical is lead, then styrene, then nickel. Next, we need to find out what the most common ways are to reduce these chemicals. Using a similar method as I did in the last slide, I found the top 10 most frequently used reduction methods. The most common activity for reduction is improved maintenance scheduling, record keeping, or procedures. But in order to further our analysis, I want to know if certain chemicals have better reduction tools to use and a higher annual reduction percentage because of it. Let's find out. I believe for certain chemicals, there can be better activities for reduction that can lead to a higher percentage. To find out if there is a relationship between the chemical, the activity used for reduction, and the percentage reduced, I used Python and found the most frequent values for each of the following chemicals. For lead, I first found the most frequent value used for the activity of reduction, which was the substituted raw materials method. And then I used this very similar splicing method in Python and found that the most common percent effectiveness of the reduction is less than 5%. Using a similar technique with styrene and nickel, I found that they all had different top reduction activities, but all had less than 5% to be their top reduction percent effectiveness. This would go against my hypothesis, stating that the chemical used, the method, and the percentage are all related. I believe now that the chemical, the reduction method used, and the percentage are not as related as I thought. I believe that you can use different methods for the same chemical and it'll still yield a less than 5% efficiency unless you are using the most effective overall activity. To find the most overall effective activity, we would need to do something a little different. Overall, in the whole entire table, the most common annual reduction percentage is less than 5%. I do believe this could be related to how expensive the reduction processes are, and that most of the reduction processes that are shorter and more cost-effective yield a less than 5% effectiveness. Looking over to the right, at the low percentage rate of 100% yield, I think this would have to do with the cost and the process of the 100% elimination. To find out more about this, we're going to have to use Python to slice where in the table there was 100% elimination, the chemical used, and the method used. From here we can see if there are any trends. Using data splicing, I eliminated the table down to just a code expansion for estimated annual reduction to be 100% elimination and to show the facility name, the chemical, the code expansion, and the industry code. This can help us analyze if one code expansion is better for 100% elimination or a certain chemical, and what kind of industries and facilities are using this method. This table shows that a number of different chemicals and code expansions were used. I do not think that one chemical with one code expansion will always yield 100%, but it is in the fabricated metals industry code using typically trichloroethylene that they were able to get 100% elimination. Another common and most common used for 100% elimination was di-2-ethylhexyl phthalate, and the most common reduction activity is substituted raw materials. As you can see from this table, each chemical is used in a variety of ways and still get 100% elimination. And all of these facilities come from different kinds of industries. This is important as a facility manager to know when trying to decide if you should start reducing your chemical waste, how to do it, and just how popular it is in your industry. As a facility manager, I want to know within my industry what are the most common ways of reduction, and should I start to do it? Here are the top 5 most common industry codes in the dataset and their most frequent source reduction activity and chemical used. From here you can see in your industry code what the most frequent source is. For the top 5 industry codes listed, they all, except one, used improved maintenance scheduling record keeping. And for the top industry code and the top chemical, it was lead, styrene, lead, dichloromethane, and lead. How frequently does my industry use reduction, and in what states? From the following, you can see that plastics and rubber is one of the most frequently used in the table as an industry name. And then the most frequent state in the EPA regulated reduction is Texas. This can help you as a facility manager with hopes of wanting to get into chemical reduction with an idea of what kind of states, facilities, and types of facilities are getting into this kind of recycling. Overall, going through this presentation as a facility manager, looking at all the pros and cons of chemical reduction, one can see that there are environmental benefits as well as costs. There are many different ways to reduce and recycle chemicals. The methods and activities can be applied in all different kinds of chemicals. Many other facilities are able to reduce successfully, and all different kinds of industries are involved in the reduction of chemicals. I would like to reduce our chemical emissions and use. What is the future of recycling chemicals? With the increase in environmental regulations and availability of recycling technology, I believe that we will start to see an increase in the amount of facilities participating in the EPA regulated reducing. I think the material, cost, and energy saving from reducing outweigh the cost of setting up these reducing and recycling activities. Maybe not for 100% elimination just yet, but in time with better technology, the 100% elimination can be easily obtainable and cost effective. Additionally, with the increased pressure from the EPA and enforcing the reductions of toxins, I hope that this will lead to more facilities wanting to recycle.